Okay, good morning, everybody, and welcome to Electrotherm's fourth installment of the Waste Heat Bottom Line. Today's webinar is titled Driving Biochar Value Through Waste Heat Recovery. I'm Tom Brokaw, the engineering manager at Electrotherm, and I'll be your host for this session. I'm really excited to have you all with us today. Before we dive in, I'd like to cover a few housekeeping items. Firstly, today's webinar will be recorded and made available for on-demand viewing at electrotherm.com, as well as on our YouTube channel. In addition, you'll be receiving an email with a link to the recording within 24 hours. We encourage you to revisit the content and share it with any of your colleagues who could not join us today. Secondly, the audio-video features have been disabled for all attendees, but we want this to be an interactive experience, so please feel free to submit your questions at any time during the presentation using the Q&A feature at the top of your screen. We've dedicated time at the end of the session, and we'll be addressing as many questions as time permits. In today's webinar, we're going to explore biochar, carbon credits, sustainability, and the addition of power generation using Electrotherm's waste heat recovery ORC technology. Presenting today is an expert in the field, Natalie Van Dyke. She's our Sales Director of Renewable Energy and Sustainability Strategies. So without further ado, let's give a warm welcome to Natalie and begin today's presentation.
Good morning. Thank you very much, Tom. I am flattered by that description. I like to think that I am knowledgeable in the area, expert. I'm not sure anyone is an active expert in this area yet. It is so evolving and so quickly moving on any given time. It is certainly a target that what you know today may not be what you need to know tomorrow. Which is sort of the point of our webinar today. But with that being said, I am Natalie Van Dyke. I am the Sales Director for Renewable Energy and Sustainability Strategies here at Electrotherm. And I'm very happy that you've joined us today, and we will go ahead and jump right in. Biochar and pyrolysis and heat recovery. A lot of people don't always think about it. Okay, everyone knows here, everyone here knows biochar is a stable form of carbon created through pyrolysis. Okay, typically produced from organic materials in the absence of oxygen. These are all known data points for this very educated group, I'm quite certain. What you may or may not particularly know is that the temperatures that are being created typically reach between 300 and 700 degrees Celsius. And this actually represents a really significant opportunity for us. We can help extend the biochar profitability through the addition of waste heat recovery power generation for pyrolysis operation system design. Most of them are not using that today, but it is a very wide open opportunity, and that's what we'd like to talk about. Our goals for the webinar today are, number one, to introduce Electrotherm. I'm sure that for a large number of you here today, this may be the first time you're interfacing with our company, so we'd like to introduce ourselves. Also, we're going to give a very high-level explanation of what the Organic Rankine Cycle is. If there are very specific technical questions at the end, we will still have Mr. Tom Brokaw, the Director of Engineering here, and he will be able to delve into those. But at the outset, understand our explanation here today is for Organic Rankine Cycle is going to be pretty high level. But we are going to examine the profitability of waste heat recovery as a system design addition that you can consider. And finally, we will be illustrating how ORC power generation can coexist with and often enhance the existing biochar production system processes that you're pursuing or maybe considering pursuing. If anyone would, I will go ahead and ask if anyone would like to in the chat. I would be, if you're willing to volunteer, I'd love to know the difference, or we would love to know the difference of how many people are currently pursuing biochar operations actively today, and how many are simply investigating or considering going that direction, or have active project plans. If you are free or interested in dropping that in the chat, we would be very interested to know. Okay, First of all, who is Electrotherm? Okay. We are the low temperature organic Rankine cycle waste heat recovery leaders in the world, frankly. Okay. We are owned by the Bitzer Group, which is the leader in refrigeration and air conditioning compressor manufacturers. They're the largest privately held manufacturers in the world of that equipment. Electrotherm itself, we have produced over 200 ORC units across 100 installations worldwide, or more than 100 installations across 14 countries. And our entire fleet, we have over 2 million operating hours at this time. And there is, I believe, we're still at about a 95 or 96% up rate with that 2 million operating hours. So we're very proud of that. Mostly, though, it's important that this we are not a startup. We are not new. We've been doing this for quite some time, and other companies that are still getting started, we have long ago solved the problems that they are just now learning exist potentially. As I did mention, we are supported by the Bitzer Group, which is the global leader in compression and refrigeration. And why is that, you would ask? The important reason is because the heart of an ORC and how it works, the heart of it is a screw expander. That screw expander is a piece of equipment that the Bitzer Group produces upwards of 30,000 of per year annually in Stuttgart, Germany. We additionally are able to support that equipment across more than 60 countries globally. And the ORC itself works as a refrigeration loop running backwards. So there's a lot of synergies between what Bitzer did and what Electrotherm does. And it's a fabulous pairing and one that we have done very, very well with. And it also gives us an incredibly wide range of reach with regard to supporting equipment globally. Okay. Now, what is Organic Rankine Cycle? At the very simplest description, Organic Rankine Cycle is a heat engine that runs on a hot fluid. In our case, the heat transfer is done with hot water. The design is very elegant and simple, and functionally, as I said, it's acting as a refrigeration cycle operating in reverse. The inorganic Rankine cycle refers to the machine's internal working fluid, which is a refrigerant. It's R245FA. And an ORC essentially takes advantage of the natural thermodynamic movement of hot liquids to create mechanical work and spin an electric generator. And that electric generator is in fact housed seamlessly within the screw expander body that is provided by Bitzer, as we discussed. Okay, so, and you can see here, I don't know if you can see my mouse, hopefully you can. We have a hot water circuit. Hot water will be brought to the machine. It will interface with a plate heat exchanger. And when it does that, it will boil the R245FA refrigerant within the machine because it has a lower boiling point than water, of course. Under pressure, this vapor is fed to the twin screw expander, which spins an electrical generator and then produces power. Okay. After that, goes outside. The vapor is then recooled in a condenser on the cold side. We'll have a cold water loop over here. And that refrigerant is pumped to the higher pressure and the cycle repeats. So essentially we have a refrigerant inside this machine. Inside is refrigerant only, but that movement of that from high to low to high to low to high to low and spinning that expander on the inside is what creates work. And that's all there is. That's all there is to it. It's really very elegant and very simple. Electrotherm, of the ORCs we make them in 3 sizes. We have a PM, soon to be 4. I'm very excited about that. Machines are small. They're nearly plug and play. They're easy to deploy, but the generator sizes range from 75 kilowatt up to 150 kilowatts today. We will be launching a larger 300 kilowatt version in mid-2024. It's currently in prototyping. Will give us a very wide range of ability. We also over here have something called an active cooler, the AC800. That's called the 800 because it can displace up to 800 kilowatts of thermal heat while creating up to 75 kilowatts of energy. This is particularly interesting because it can provide a guaranteed return temperature to a biochar or some other application, some other need, and we'll talk about that a little later. But rest assured, the best thing to understand right now is that it can provide a cooling benefit, and it is utilized to target replacement of electric coolers. So if you're using electric coolers in your current biochar application, this can be a very nice drop-in replacement for that. Now then, how does it, we said that we need hot water to work. Where do we get the hot water from? Literally, we don't care. That's the simplest answer. We are diverse and flexible and completely heat agnostic. As long as we have water in the temperatures between 150 and 300 degrees Fahrenheit, or 75 to 150 degrees Celsius, we are able to utilize it. We can do that with pyrolysis equipment, obviously, but we can do it with any of these others as well. Compression heat recovery, engine waste recovery, any industrial process, biomass or biogas, combined heat and power. All of these, again, we are completely heat agnostic. If you can create hot water, we can create energy. That's the bottom line. And with pyrolysis, we can absolutely create that hot water. Now then, looking at biochar specifically, let's be frank, okay? If you're here today, you're likely already pursuing a business strategy, taking advantage at least one and likely multiple of these profitability value streams that exist with biochar. We have a carbon economy, the circular economy, and a renewable energy economy. Under waste management, you may be doing disposal of a feedstock as a paid service, or collecting from one or more producers which had previously paid to transport and eliminate their waste in a more costly landfill. Alternatively, maybe you are a producer of the feedstock waste material, and the biochar represents an opportunity to significantly reduce your own waste management costs. So you're enjoying an avoided cost there. Under soil improvement, your operation is or will be producing and selling biochar as a profitable commodity for agricultural or supplemental building material use, perhaps. Alternatively, if you're an agricultural operator yourself, maybe you'll be your own off-taker for the biochar, and you'll be fully utilizing it as you produce it in your own primary operations and create your own circular economy while reducing your projected fertilizer expenditures in the future. We actually have a customer doing this right now, a very large agricultural corporate. We are not able to disclose who it is, but seeing how they've integrated their biochar application into a full circular economy and integrated ORC has been very, very exciting to see. It's really quite impressive. With that being said, the star of the show here is undoubtedly carbon sequestration. It seems to be the primary driver for many, if not most, biochar operators today. And if this brings us to this does bring us to the subject of carbon credits and carbon certification. This is the profit center of greatest interest to most everyone on the call today, and this is why adding zero emissions waste heat recovery energy production with Electrotherm is an opportunity. It's really an opportunity for a system design advantage you can easily add today, and indeed proving highly effective levels of energy efficiency of your pyrolysis system. Could be an operational mandate for monetizing biochar carbon credits in the future. You may have to prove in the future that you can be efficient, and this is one opportunity that you can take today to do that. So let's dive into that a little bit and explore it. future-proofing pyrolysis operations for Biochar certification. When you have a key profitability goal, and it hinges on creating high quality or high technology biochar, and those are phrases that you'll hear often in the industry, high quality or high technology. Do not neglect waste heat energy production in your system design. You see here, this is the cover of the European Biochar Certificate Guidelines. You'll often hear it referred to as the EBC for shorthand. It's a 71-page document many of you are no doubt highly familiar with. It provides guidance for producers of biochar in all areas of operation and sets goals for standards for biochar product quality. If you go to their website for the EBC, one of the first things you're going to see is the EBC is currently on version 10.3. This was only established as a growing concern in 2012. That's 11 years ago. And they're on version 10.3 of the guidelines. This thing is ever evolving. It is a living thing. And as such, it is also a moving target for you as a biochar producer. Indeed, there have been 2 revisions of the EBC in just the last 12 months. So it is definitely going to keep you on your toes. If we dive into it, though, and many of you, again, are probably well versed in this, but if you look at Section 8 in that 71-page document, you're going to see the EBC deals directly with pyrolysis operations, and it has quite a lot to say about energy efficiency, waste heat recovery, and renewable energy, as you can see here. Section 8.1, pyrolysis must be operated in an energy efficient manner. The use of renewable energy sources or surplus electricity is recommended. If we go further in Section 8 to Section 8.4, it gets very specific and says 70% of excess heat must be utilized in order to meet the threshold for EBC certification. Okay, 70%. Now, granted, many of you are using that heat for another approved function today, which is drying of feedstock or perhaps another agricultural use, such as direct heating of floor heating in barns. I've been told that chickens are happier when they have warm feet. I can't speak to that directly, but that's what I've been told, and this is one use that we hear from time to time. And we'll get back to that later. But the excess heat must be used at least 70% and for generating electricity and or similar sustainable purposes. For now, remember the EBC has stated biomass pyrolysis must be operated in an energy efficient manner, as it stated earlier, and that this document evolves frequently. So the potential that drying alone will be sufficient heat utilization as a definition of efficiency in the future, that's really not guaranteed. That's an important takeaway here today, is that what you're doing today to meet that 70% threshold may not get you where you need to be in the future. Now, I can almost hear some of you saying, Natalie, I'm not operating in Europe. I'm going to be using a different certifying body here in North America. So why? Why do I care? Valid point. Completely true. However, I've listed some of the other validating bodies here. You can see Vera, American Carbon Registry, Puro Earth. And understand the EBC is the leader and the standard upon which most of these other bodies are at least basing their certification framework. Additionally, the market competition in the US will be driving all of these organizations to demonstrate that each of them is meritorious of the title of most trusted and most green. That's the goal that they're each going to try and reach. Energy efficiency and waste heat utilization metrics, without a doubt, are going to be attributes of biochar processing, which, if not completely required for certification, and it may not be completely required, according to the letter of the certification, it will be tracked, it will be quantified, and it will be reported to potential carbon credit consumers. And I am here to tell you, understanding that now can work to your advantage. Biochar and certified carbon credits with higher energy efficiencies and which produce electricity from their waste heat are likely to be in higher demand by consumers and command a greater price on carbon markets. Let me say that again. Efficiencies are likely to be, higher energy efficiencies are likely to be in higher demand by consumers. They are going to command a greater price on carbon markets. Plan for this now. Know it's going to be true. Design your system accordingly. How do we know this? We know this because we've already seen it in the renewable natural gas fuel market. Discerning, sophisticated consumers on carbon credit markets, some of the largest which are shown here. You can see Google and Microsoft, Meta, Shell and Chevron, Volkswagen. I mean, these are not small names. They all want to know the credits they're purchasing are produced with the highest level of process integrity and unassailable in their environmental credentials. Credits and biochar both will be judged for total carbon reduction. Both the credits and the biochar are going to be judged for total carbon reduction pedigree, likely measured as something called a carbon intensity score. Those judged as thoroughbreds will be worth more money to their producers. You see here, we have a certificate and we have money. Here we have energy in a certificate and we have more money. That's the takeaway. You're going with energy, with efficiency. Your credits and your biochar output are going to be worth more money. That is the prediction we're making. Why are we making it? Glad you asked. Let me explain. We know there's going to be worth more because we've already seen this in the renewable natural gas fuel markets. Reducing carbon intensity, which is also known as a CI score, has been predictive of commodity value increase in renewable natural gas markets historically. The key here is the CI score, which, let me explain. A CI score is the backbone behind California's low carbon fuel standard, which you may have heard of. Sometimes you hear it, but it's CARB, okay, the LCFS. The CI, it is measured in grams of carbon dioxide equivalent per megajoule of energy. I know everyone knew that intuitively, so I'm going to say it one more time. A CI score is measured in grams of carbon dioxide equivalent per megajoule of energy. The carbon intensity of a producer's fuel is inversely proportional to the value at which the fuel trades on markets. Okay, inversely proportional. That means the lower a producer can bring their CI score, the higher price their fuel will be worth on the market. Renewable natural gas operations have been fighting mightily to drop their carbon intensity score as low as possible by engineering and energy efficiency, knowing this is a manner for increasing their profits. They want their commodity to be as valuable as possible. How do you get it as valuable as possible? They reduce their carbon intensity, okay, the amount of energy that they're expending. How are they doing this? Well, coincidentally, one way they're doing is by integrating ORCs for waste heat recovery so they can displace their baseload energy usage from the grid. A lot of these places are using energy from grids that utilize carbon or coal rather for energy generation. That's highly intensive, and they are measured on that. That is a metric that is absolutely calculated for them. So every megajoule that they can displace from that grid, and they create on their own and their own operations by doing waste heat recovery, helps them diminish their carbon intensity score and increases the value of their commodity. Excuse me. I can't go too deeply into this as it's a huge topic. I've done entire webinars on this alone, okay? But I've placed 2 links on this slide as resources for anyone interested in examining this important topic more closely. Additionally, anyone can call me at any time and I'll geek out on CI score with you as long as you'd like. But if you are not familiar with this term, have not heard it before, definitely follow the resources at the bottom. Give yourself some education on it. and understand that it is probably going to be extrapolated toward biochar, and you should be able to understand how that is going to impact your credits and your biochar product totally. I'm going to take a small sip of water. One moment. Oh, that's much better. Thank you. Okay, caveat time. I have a lot of very good traits, but I am not, nor is anyone at Electrotherm on the Electrotherm team, a tax accounting professional. So all statements here should be validated with your own financial tax advisors. But I would like you all to consider opportunity cost. Right now, tax credit financial advantages for R&D and project test projects under Section 48E of the tax code are very attractive. Waste heat recovery projects are currently enjoying a financial moment of glory, quite frankly. The CapEx, which will be required to increase the energy operating efficiency of your biochar pyrolysis venture, has never been more attractive. And this is due entirely to the minimum of 30 to 50% tax credit available thanks to the IRA, okay? There are two important points here. You will see I highlighted them. Number one, notice language says project cost, okay? That's been described to us by several tax firms as potentially meaning the cost of the pyrolysis unit as well. Let me say that, not just the ORC, but the pyrolysis units as well, when it's paired with a waste heat recovery ORC, as well as the necessary hot water loop between the units and the cooling equipment. Buy America content provisions and domestic content levels would matter here, okay? That 30 to 50%, there's fluctuation based on content, and we'll investigate that in a minute further, okay? But the pairing of the ORC for, excuse me, the pairing of the ORC for energy creation with the pyrolysis unit can reportedly create a halo effect of tax protection over the pyrolysis unit as well. So if you're getting a 30% tax credit on the ORC, but then you can extrapolate that to the entire project cost, then you can get a 30% tax credit on the ORC, the water loop, and the pyrolysis unit to create your biochar as well, because that represents an entire project. Again, all of this has to be vetted with your attorneys, our tax accountant people, but this is very, very intriguing in terms of opportunity. We are currently working on a formal letter of opinion from an energy accounting firm on this item. So stay tuned with us and stay in contact with us for official updates on this topic soon, hoping for something as soon as possibly the end of next week. The other opportunity here, important takeaway here, is the language that says includes direct pay and transferability. Some of you are saying, Natalie, I don't generally owe taxes. I'm a nonprofit, I'm a municipality. Why does this affect me? How does generating a tax credit even help me? Well, guess what? The IRA has provisions which will allow entities to negotiate the sale of tax credits for cash. You can take your tax credit, you can go to somebody else that needs a tax credit and say, I'll sell you all of mine at this amount. And there are currently exchanges that exist for that. It is complicated. I'm not going to pretend it isn't. If you are a tax exempt organization or a municipality, you also have the opportunity that there are provisions in the IRA for your organization to receive direct payments. If anyone wants additional information on either of those items, send us a message or a call. It's too dense to go into here in depth, but we do have tax pros that we can put you in touch with to give you the full lowdown on how this very deep, dark accounting black magic actually works. But it is very intriguing. The biggest takeaway to understand, though, is that the new clean electricity investment tax credit, which is listed as 48E, it's a newly established tax neutral or tech neutral ITC. It replaces the old energy ITC one that will be phased out at the end of 2024. 48E is an emission-based incentive that is neutral and flexible between clean electricity technologies. So waste heat recovery can absolutely take advantage of it. And it does create an ITC of 30% of the investment for your entire investment. It does apply a 10% bonus for projects located in energy communities, defined as brownfield sites or fossil fuel communities. When I say fossil fuel communities, read that as someplace that used to have a coal-fired power plant or has oil fields. I like to consider it the Joe Manchin bump. But that is what that applies to. And the other 10% bonus is for meeting domestic manufacturing requirements for steel, iron, or other manufactured components. Electrotherm equipment does in fact meet those thresholds. So that it represents a significant financial opportunity. Then past that, let's talk about deployment. How you've talked about why you should do it, why it's more profitable, how you could pay for it. Now, how tough is it? How does this affect my operation? In this instance, the things that you need to know about the Electrotherm unit, the ORC, is it has a very small footprint. Installation is extremely minimal with plant and facility impact. Additionally, it's easily containerized, so it can be placed almost anywhere. You're given the immediate availability of carbon neutral zero emissions energy production for on-site use or deployment back to the grid. In most instances, you're not going to be creating enough energy to deploy back to the grid. You're going to be offsetting your actual base load. But some of you may be very large operators with multiple biochars and pyrolysis machines. So in those instances, do be aware that it can be deployed back to the grid. It is as near a plug-and-play energy solution as available today. You connect your unit to the pyrolysis with a water loop to deliver hot water to the ORC. And you give us access to a 480-volt motor-rated circuit breaker, and that's all we need. It's kind of like plugging in a refrigerator in your kitchen. You give us water to the ice maker, put it, plug it into the wall, and the refrigerator will sit there and work. This is very similar to that. The actual internal componentry for the thing is less than you would anticipate. So management of it and the servicing of it is not very difficult. Most refrigeration and air conditioning certified individuals can handle it. It is modular and redeployable, so it can be delivered on a skid if it's useful to do that. And if you envision moving your biochar operation in the future and relocating the ORC with it is entirely possible. You can move it around. You will have to make sure you have a new water loop on those locations, obviously, but that's just piping. It's not that difficult. And then finally, you have remote fleet control available. No on-site operator is necessary for this. So some of your operations, I know, you put these things on there and this is a batch process. Do you have to have someone sitting there watching the batch, or do you have to have someone watching your ORC during operation? The answer is no, you can do that remotely. Let's see. Okay. ORC integration for pyrolysis is comparatively easy, okay? I don't want to, this isn't a show-off thing, but we have done this many times for much tougher applications. As I've stated, this is near plug and play as is available today. You connect our unit to the pyrolysis with a water loop to deliver hot water to the ORC. And as long as we have access to that 480-volt motor-rated circuit breaker, that's really all we have to do is get the hot water, have supply of a cold water, which we can, in fact, do on our own. But your pyrolysis unit likely has a need of a cooling function of some nature currently anyway. You have the ability to pull that heat and create energy with an ORC rather than expend it with some other existing cooler, which you may have, okay? Any cooling unit you're currently utilizing would represent a parasitic energy load anyway, thereby increasing your CI score. as we discussed. Replacing or dialing down the necessary usage of that cooling unit in your current design will likely be very beneficial to your overall system efficiency. Obviously, that's case by case, and we have to look at it, but the trend or the belief that we will bring an efficiency to you there is very high. Finally, everyone we talk to, and I mean everyone, is doing something important, which is their real mission. Nobody got up this morning and said, I'm going to be an ORC mogul. Nobody's doing that. Everybody is doing something else. An ORC is a secondary ancillary thing. Okay, the ORC implementation in your design will not interfere with your primary business mission, which in this case is handling feedstock, creating biochar, and generating carbon credits. If we as a technology messed with or threatened that primary function, we wouldn't remain in business very long. This image there, that's what I'm looking for. Okay. Things were missing. I was like, why is this slide so empty? There we go. You see here, these are all other applications that we have utilized, that we have worked on. Engines, exhaust, engine cooling systems, boilers, industrial cooling systems, district heating, geothermal oil and gas wells. These are all very, very intensive, very important issues. We're able to work with them because we're heat agnostic, as I discussed. But all of these operations have had ORC successfully integrated with them. Okay. These are all examples of applications well outside biochar pyrolysis. But we have currently integrated with biochar and all of these successfully. In each of these, maintaining the operation without creating pressure drops within the larger primary system is 100% critical, and it has been 100% entirely achieved. So you can rest assured that using an ORC with pyrolysis can be done stably and safely without impacting your primary mission of biochar creation. Then finally, we can enhance existing biochar system processes pretty effectively. We talk about the rejected cold water. Cold water from our technology often you can see here, we've got the pyrolysis unit, and we have hot water coming over to the waste heat to the ORC, but then we have rejected heat again. This is, you can see it's still red. It's a little less red, but it's red. We have extracted heat, but that doesn't mean it's cold water exactly. The rejected cold water from our technology maintains enough heat to continue supplying the needs of existing mission-critical operations quite frequently, such as feedstock drying, providing heat for anaerobic digesters. The anaerobic digesters is why I labeled this as 108 degrees, because that's the number that 108 to 110 anaerobic digesters really, really like that. And we can supply that as a guaranteed return temperature for your downstream application usage. And that's able to exactly meet the needs of those processes. So it's important to understand ORC is not and should not be considered different or in lieu of the existing heat needs that you have. It can be integrated and utilized very effectively together. In fact, in the UK, I've lost track of how many applications we have with ORCs that are supportive of feedstock drying and ORC production in biomass. It's a very large number. In conclusion, wow, and I'm on the 40-minute mark, right where I wanted to be. I don't believe it. Okay. In conclusion, to driving the value of biochar, the important takeaways today that I think are very useful to this market is, number one, certification requirements for biochar credits is a moving target. It is all over the place, and future-proofing this is key. As you are considering future-proofing your particular operation, do not forget waste heat utilization and the opportunity that represents. Number two, the heat utilization you're pursuing today to meet that 70% usage threshold that you probably have for your certification, that may not be sufficient for credit certification in the future. Bear that in mind. Even if it is sufficient, also bear in mind that you still have to meet the expectations of key consumers focused on aggressive green initiatives. They have set 2030 targets. They have set 2040 targets. They have set 2050 targets. They are going to buy from whoever is the most energy efficient and who is ever going to give them the best byline in their next press release. You need to have the most energy efficient product if you would like to be the people that are in that press release. Number 3, carbon intensity score will likely be a key market driver. Learn what it means. Plan now to meet this challenge, because your competition's going to know what it is, and they're going to be driving toward that goal. If you need to understand this more clearly, again, we just scratched the surface. Feel free to contact me. Feel free to contact any of our other sales representatives here at Electrotherm. We will all be more than happy to discuss it with you and give you the lowdown on how that works. Excuse me. Number 4, opportunity cost. Take this away. Understand the funding available under the Inflation Reduction Act right now is a fabulous opportunity. Okay, you can massively drop your CapEx for a full project if you understand how that works. Talk to your tax pros. Call us. We'll give you tax pros to talk to. We will give you a leg up. But definitely, you are cutting yourself short if you don't look at that and understand how that halo effect for the ITC could, in fact, reduce your cost of biochar equipment as well as the Electrotherm equipment. And then finally, deployment of organic Rankine cycle technology, strategic financial benefits. As you're looking for financial benefits, you are not going to interfere with your primary mission. Your primary mission today, tomorrow, we understand, is creating high quality biochar, high technology biochar. That's your goal. You don't want to think about ORC. You just want to reduce your CI score and have this thing be more profitable to you. And I'm telling you today, Electrotherm ORC energy creation is a very good way to do that and embrace that. And it can be a real benefit to your operations. So in conclusion, thank you very much for participating. We very much look forward to speaking with you soon. I hope that this has been valuable.